Hello there. Good morning, good afternoon, or good evening, whenever it is that you are watching this video. So this is our sixth video in our video series for Chapter 9, Homeostasis. And in this video, we will enter into the last subtopic, which is 9.3D, blood water regulation by ADH, also called Antidiuretic Hormone. Okay, first things first, we need to know the concept behind this topic, which is that we know that kidneys play a central role in the regulation of water content and salt concentration of the body. So, kita punya buah pinggang yang jaga osmoregulation, which is dia jaga berapa banyak air dan dia jaga berapa banyak garam ada dalam badan kita. So how it does that is the water content of the blood will be monitored by osmoreceptor cells in the hypothalamus. So these osmoreceptor cells will detect the water content in the blood, and then they will secrete antidiuretic hormone called ADH. And what will ADH do? ADH will increase the permeability of the walls of the collecting duct and distal convoluted tubule to water. ADH akan suruh distal convoluted tubule dan collecting duct dalam kita punya buah pinggang untuk serap lebih banyak air. So we'll look at the components of this osmoregulation system one by one. Okay, dengan ringkas sajalah, tidak susah pun topik ni. Okay, osmoreceptor are receptors that are found in the hypothalamus to detect the changes in osmotic pressure. Dia yang detect kandungan air di dalam darah. Hypothalamus is the part of the brain that will produce the antidiuretic hormone, ADH. And the posterior pituitary gland in the brain will secrete or control the release of ADH. So ini sel ini yang akan detect, lepas tu hasilkan hormon tu. Dan yang tolong kasih keluar adalah posterior pituitary gland. Last but not least, the component of the osmoregulation system, number 4, is ADH, antidiuretic hormone. So, antidiuretic hormone will increase the permeability of distal convoluted tubule and collecting duct to water. Increased permeability means dia akan menyebabkan sel-sel di distal convoluted tubule dan collecting duct untuk lebih senang osmosis. Increased permeability menyebabkan molekul air senang untuk limpas tisu-tisu di sana. Okay? Increased permeability. ADH is also called vasopressin. Itu nama lain ADH. Tapi dalam syllabus kamu, kalau kamu guna ADH saja pun boleh. Okay, so let us get to know this ADH. Mari kita tengok ADH ni dari mana dia datang, mana dia pergi, apa dia buat, dan apa yang akan menyebabkan dia dihasilkan. Okay, ADH, this hormone, is produced in the hypothalamus. It will be released by the posterior pituitary gland. Dihasilkan di hypothalamus, dikeluarkan oleh posterior pituitary gland. Mana dia pergi? The target tissue is the distal convoluted tubule and collecting ducts that is in the nephron in the kidney. What does it do? It will increase the permeability of the collecting ducts to water, thus increasing the reabsorption and decreasing water excretion. Apa maksud ayat ni? Dia akan menyebabkan distal convoluted tubule dan juga collecting duct untuk senang serap air, increasing reabsorption, makin banyak air yang kena serap semula, dan decreasing water excretion, mengurangkan kandungan ataupun bilangan air yang dikeluarkan daripada badan, yang dikencingkan. What are the factors that will stimulate the release of ADH? What tells the hypothalamus to make more ADH? The factor is low fluid intake. When you have low fluid intake, it decreases the blood volume and increases osmotic pressure of blood. Kita punya blood volume, like the volume, how much blood we have, will decrease a little bit. And that means the osmotic pressure of the blood will increase. Okay, if you are curious, this is what is meant by osmotic pressure. Kalau bingung pun, kalau bingung tidak apa, ignore. If you want to try to understand, you can try to understand this thing. Osmotic pressure is the minimum pressure which needs to be applied to a solution to prevent inward flow of water across a semi-permeable membrane. So, sepatutnya kalau air itu at normal osmotic pressure, maybe it goes this way. When you have increased osmotic pressure, ada kemungkinan air, rather than going this way, it's gonna go the other way. Ataupun dia tidak limpas pun. This is also defined as the measure of the tendency of a solution to take in water by osmosis. If you understand those points, that is great. Good for you. If you don't understand, that's all right. We don't need to remember that. Just know that if the osmotic pressure of the blood changes too much, that's not going to be good for our tissues. So we need to take care of the osmotic pressure of our blood. Okay, so going back to the factor that simulate release, the receptors in the hypothalamus will stimulate the posterior pituitary gland to secrete ADH. So dalam sini, basically apa yang dia cakap adalah kalau kita kurang minum air, apa terjadi, siapa akan keluarkan ADH. Let's look at a situation where we have low intake of water. Macam sekarang, saya haus. Apa yang berlaku dalam otak dan saya punya buah pinggang? Saya haus, low intake of water. So we'll start looking at it one by one, okay? So when the water content of the blood is lower than normal, this is causing the blood volume to decrease. Therefore, the concentration of salts dissolved in the blood becomes greater, causing an increase in blood osmotic pressure. In case you're having trouble with this sentence, I'll try to explain it one by one, ya. Bila kandungan air dalam darah kita kurang daripada normal, ini akan menyebabkan volume darah untuk mengurang. Kemudian, sebab kandungan air kurang, tapi kandungan garam masih sama. In a way, darah kita makin pekat. Concentration of salt dissolved in the blood become greater, means darah makin pekat. So this will cause an increase in blood osmotic pressure. What happens next is the osmoreceptor in your hypothalamus will detect the changes and stimulate the posterior pituitary gland to release more ADH. Osmoreceptor itu dia dapat detect there is increase in blood osmotic pressure, time to make ADH. ADH will be released into your blood, and when it reaches your kidneys, ADH will increase the permeability of distal convoluted tubule and collecting duct to water. So, bila dia sampai kepada buah pinggang, dia akan increase permeability of distal convoluted tubule and collecting duct to water. What happens next is you will have water reabsorption from renal filtrate into blood by osmosis increase. Semakin banyak air akan diserap semula di dalam kita punya nephron. So, a small volume of concentrated urine are produced. Kencing kita semakin sedikit dan semakin pekat. And this water retention causes the blood osmotic pressure to decrease. Disebabkan lebih banyak air diserap semula ke dalam badan, kandungan air dalam darah balik kepada normal. Kandungan air balik kepada normal means blood osmotic pressure decreases back to normal. Okay, so these diagrams, if you see them in your notes, this is to explain how blood osmolarity is maintained when there is increase in blood osmolarity. Kalau kita kurang minum air, osmotic pressure increase. And the brain, first thing first, is it will secrete ADH. And also at the same time, it will tell the other parts of your brain to drink more water. That is what is being explained in this part. And ini fokus kepada ADH sahaja. Okay. If you don't want to memorize this diagram, that's fine. Not a big problem. Kita punya syllabus cuma fokus kepada penggunaan ADH. So, tidak payah pikir pasal, oh, kita haus, apa kita buat bila kita haus. Okay, so let's look at the situation where you have high intake of water. Ya, contoh dalam contoh ni kita minum banyak air, minum more than usual. So what happens when you have high intake of water? The water content of your blood will be higher than normal, causing the blood volume to increase. Therefore, the concentration of salts dissolved in the blood become less, causing a decrease in blood osmotic pressure. Apa yang dimaksudkan di sini, in case kamu kurang paham? Bila kita minum banyak air, kandungan air dalam darah lebih tinggi daripada biasa, menyebabkan volume darah itu semakin meningkat, makin banyak. Sekarang kandungan air semakin banyak, kandungan garam sama saja. So technically your blood is lebih cair. Darah kamu jadi lebih cair, dia lebih dilute. Therefore we can say concentration of salts dissolved in blood become less, thus causing a decrease in blood osmotic pressure. What happens after the blood osmotic pressure decrease? Osmoreceptor in the hypothalamus will detect changes and then stimulate the posterior pituitary gland to release less ADH. Bila osmoreceptor detect, okay, there is decrease in blood osmotic pressure. Banyak air ni. Posterior pituitary gland, sila kurangkan berapa banyak ADH yang kamu hasilkan. Sometimes you can say release less ADH, sometimes you can write inhibit release of ADH. What happens when there is less ADH is the distal convoluted tubule and collecting duct become less permeable to water. Susah sikit sudah untuk air limpas membrane, distal convoluted tubule and collecting duct. So water reabsorption from the filtrate into blood by osmosis decrease. Water reabsorption kurang. And large volume of diluted urine are produced. Kencing kita semakin banyak dan semakin cair. This water loss causes the blood osmotic pressure to increase. Sekarang lebih banyak air disingkirkan daripada badan, blood osmotic pressure balik kepada normal. Tingkat balik kepada normal. So that is it. It's kind of just a bit reverse of the other one. Okay, so I don't have a diagram for high intake of water. I hope that these sentences make sense. And yeah, that is the end of this. I just have a quick food for thought, just a quick question. Okay, these guys are traveling in the desert, right? So they don't have a lot of water. What's gonna happen to them if their brain suddenly has a problem and their hypothalamus fail to increase the levels of ADH? Bayangkan kalau kamu sudah kurang minum air, tapi otak kamu tidak hasilkan ADH. What's gonna happen to your body? How long will you survive? That's it for the high order thinking questions. Now, what you should do is please complete the worksheet for 9.3, which you can find in the Google Classroom. And in addition, please also complete the tutorial questions for Chapter 9, all the questions if possible, and hopefully that will help you enhance your understanding. Let's end the video with a really quick summary on what we've learned in this chapter, which is the concept of homeostasis, negative feedback mechanism using the example of regulation of blood glucose, and last but not least, in this last 4 videos, you've learned about the human kidney functions and how it carries out homeostasis in our body. Thank you very much for your time and your attention, and I will see you again soon. Bye!